Okay, so I want to run through number 30 in the chapter 2 review because this is a good polynomial equation to find the zeros for because it involves all the things like Descartes' rule of signs and upper and lower bound theorem and those things. So I thought it'd be good to run through it real quick. So we have f of x is this fifth degree polynomial, and we want to find the zeros. We want to find the values of x that make it zero. So we're going to look at the signs here, the sign changes. So we've got one sign change, 2, 3, 4. 4 sign changes means that that f of x has 4 or 2 or 0 positive real roots. So it has 4 or 2 less than that or 2 less than that. So there are 3 possibilities about how many positive real roots there will be. If we look at f of negative x, and there's only one sign change there, so there will be one negative real root. Okay, so that's really nice because that tells us definitely there will be one negative real root, and that's the only possibility. So we can set up a little chart to get an idea of what the scenarios might be. First of all, we know no matter what any of the other things are, there will be one negative real root. The positive real roots, we said, there could be 4, there could be 2, there could be none. And so since the number of roots has to be 5, because this is a fifth degree polynomial, we know that if there are 4 positive real roots and 1 negative real root, there won't be any non-real roots because that already adds up to 5. If there are 2 positive and 1 negative real root, that leaves 2 roots left, so those would be non-real. If there are no real positive real roots and there's still 1 negative real root, then there would have to be 4 non-real roots to get all the roots we need. Okay, then if we use the rational roots theorem, we can figure out what all the possible rational zeros would be. And there are they represented by all the factors of 40 on top and the factors of 2 on the bottom. So if we look at that, we have plus or minus 1, plus or minus 2, plus or minus 4, all those up to with plus or minus 1/2 and plus or minus 5/2 as the possible rational roots. So I'm going to start out by looking for that negative real root because we know it exists. And so I'm just going to start with -1 because it's easy. So I'll set that up and then bring down the 2. 2 times -1 is -2. Add them up, you get -9. -9 times -1 is 9. 18, -18, -36, +36, and that makes 40, and then -40. So that is a 0. So we got our negative real zero. That's it. We don't have to look for any more negative ones because that's it. If you look at the signs on the coefficients there, you've got a +2, -9, +18, -36, +40. So the signs alternate, which means that that is a lower bound. So -1 is a lower bound, and we would expect that because we know there are no other negative real roots. There can only be roots above -1. Okay, so we have our factorization so far. If -1 is a root, then x minus -1 is a factor, and so that's x plus 1. And then we have what's left over, which is that reduced polynomial, 2x to the 4th minus 9x cubed plus 18x squared minus 36x plus 40. All right, and if we go back and use the rational roots theorem again, we get the same exact numbers because we still have a constant of 40 and a leading coefficient of 2. And so we're just going to move on and try some positive real roots now. So we'll try 1 to start with since it's easy. So we'll bring down the 2. 2 times 1 is 2. Add them up, you get -7, -7, 11, 11, -25, -25, 15. So 1 is not a 0. It's not a root of the function, but we again have these alternating signs to -7, 11, -25, 15. So this tells us that 1 is a lower bound, and that means that all the real zeros have to be above 1, and that tells me that I can get rid of 1/2 because it's below 1, and 1 is the lower bound. There are no zeros below 1, so 1/2, I can get rid of that one. All right, so here's where we are right now. We've gotten rid of the 1, we've gotten rid of the 1/2. we're still, I mean, we've gotten rid of the positive one. We know negative one is a root, and x plus 1 therefore is a factor. And we're going to keep trying positive roots. So I'm going to try 2, and if I do that, so I find out that 2 actually is a 0, so that's one of our positive real roots. And I know that, so if there's 1, I know there must be at least one more, because I can have 2 or I can have 4. So the factorization now is x plus 1 for my negative 1 root, and then x minus 2, since 2 is a root, x minus 2 is a factor, and then I'm left with 2x cubed minus 5x squared plus 8x minus 20. So now if I try the next positive root above 2, I'll just try 4 because it's a whole number. So I'll try 4, and it's easier to do 4 than it would be to do 5 halves. And if I do that, bring down the 2, multiply, you get 8. Add, you get 3, 12, 20, 80, 60. All right, that's not a 0, but it tells me something very important, and that is that 4 is an upper bound. That means there are no zeros above 4. The way that I know that is because after I did that synthetic division with the 4, all the coefficients turned out to be positive. So here's what we have so far. We tried negative 1, that gave us a 0, so we have a factor x plus 1. We tried positive 1, it didn't work, but it did tell us that 1 was a lower bound, meaning that nothing lower than 1 could be a 0, so we got rid of the 1/2. We just tried the 4, it didn't work, but it did tell us that 4 is the upper bound of the zeros, meaning that there are no zeros above 4. So we've gotten rid of everything except 5 halves. 5 halves is the only choice left. And we'll multiply and get 5, and then 0, 0, 8, and 20. And 5 halves is a positive real root. So now we have negative 1, we have 2, and now we also have 5 halves for our third real root. So we have 1 negative, 2 positives, and that's going to leave us with 2 more to see what those are. So we don't have any more rational roots. So these could possibly be irrational, but real and positive, or they could just be non-real. So our factorization now is going to be x plus 1 times x minus 2 times x minus 5 halves, and we're left with 2x squared plus 8, and the solutions for that are easy. We just set it up. 2x squared plus 8 equals 0. Subtract 8 on both sides. Divide by 2, and then take the square root on both sides. And so we'll have plus or minus 2i, which would be 2 non-real roots. So we ended up with 2 positive real roots, 1 negative real root, and 2 non-real roots.